of change, we utilize the chain rule. So what I'm going to do before we even do this question, I'll just quickly let us revise the chain rule. Teachers, just give me 1 minute. All right, so let's revise the chain rule. I'm really sorry about that pause. So let's say we have a function y is equal to 8x minus probably 3. Well, let me use 8x here, yeah. Minus 3x to the third power. And we're asked to find dy dx. This here is a typical example of when we apply the chain rule. The chain rule is also called the function of a function, when we have a function in another function, right? Like what we call the composite function that we would do for CSEC, the composite function, like when you find g of x or f g of x, things like that. Yeah, like f g of x or g f of x in this type of like this. Just so that we're on the same page. Anyone can remember these functions? Composite function? It's such a function. We use what we call a u substitution. So I can say let u equal to the inner function. So the inner function would be this here. So u would be equal to 8x squared minus 3x. So if I let u equal to this inner function, I can rewrite y as y is equal to, can someone tell me? So y is equal to u to the third power. Is this clear to everyone? Or any?
Yes, sir.
Right?
Yes, sir.
So this is how we engage with the chain rule. We use what we call a u substitution. Right? So before I go any further to do any of this, let me just put another one. Because it makes no sense moving on if we are not comfortable here. Good. So let's say we have a function y is equal to and we're asked to find dy dx. Good. Now how do we go about doing this? What will be our u in this case? What will we let u equal to?
X squared minus 1.
Excellent, excellent. So we let u equal to x squared minus 1. So now I can rewrite y in terms of u as y is equal to what?
So the root of u?
Excellent. So where I had x squared minus 1, remember I'm saying that u is equal to that. So I'll write it as y is equal to the root of u. Is this clear with everyone? Engage with the chain rule. So I'll do one more before we actually work this out because I feel strongly that we have to go with the chain. So let's say we have y is equal to cos 5 cos 3x. Good. What are we going to let u be equal to in this case? Let me take out the 5, just for simplicity's sake. Yeah, what are we going to let u equal to in this case?
3x, sir.
Very good. Because cos is a function by itself, and 3x is another function. Teachers, just give me a minute. Let u be equal to 3x. So we can rewrite this function as y is equal to cos what?
U.
Very good. Because we allow u to be 3x, so y will be equal to cos u. Right. So this, again, this is how we engage with the chain rule. So now I'm going to go back here and we're going to differentiate using the chain rule now. So what the chain rule does, we are going to differentiate both of these here. According to the chain rule, remember what we want, right? We want dy dx. In order to get dy dx, this is the general formula for the chain rule. Dy dx is equal to dy du times du dx. So if for some reason we forgot this, you never did this before, just make a note of this. This is what the chain rule is all about. In order to find dy dx, which is our first derivative, we use this formula. Dy dx is equal to dy du times du dx. That's basically it. Are we good so far? Y du. I have u is equal to, sorry, I have y is equal to u cubed. So if I differentiate this function, I will get dy du, because the two variables that I'm dealing with are y and u. So that's how I'm going to get dy du, by differentiating my new y function. So when we differentiate u cubed, what will we get?
3u squared.
Excellent. 3u squared. Right? So basically, to differentiate, remember, we multiply by the power and we take 1 from the power. So that's our dy du. So let me just make that substitution right away. So where I have dy du, I'm going to write now 3u squared. Can someone tell me what's the next thing I have to find?
Du dx, sir.
Very good. So now we need to find du dx. Remember, we have u is equal to 8x squared minus 3x. So if I differentiate this function, u with respect to x, du dx, can someone else tell me what that will be when we differentiate this function? Du dx, what will we get? Come on, there are several persons in this class. We're differentiating 8x squared minus 3x. Eight x squared minus 3x. 16x minus 3. Okay. Great. So where I have du dx, I'm going to put now 16x minus 3. Now the final stage of this work in here, let me take all this out. What we need to do from here is simplify. Right? So one of the first things that we like to do is substitute back now our value for u. So let's go up. What was our value for u? U is equal to 8x squared minus 3x. So after you find your dy du and your du dx, all you need to do is simplify. Okay? So that will give us 3, substituting my value for u was 8x squared minus 3x minus 3x squared. So that's our 3 here, and this is u, and then I put a square on the outside. This is good with everyone. U is 8x squared minus 3x, and I put back my square on the outside. So what do I have to write next? Wonderful. So I can just put a bracket times 16x minus 3. So basically this is our answer. It can be simplified, but this is basically our answer. So this is how the chain rule works. So we'll come over to the second example. I'm not going to take anything for granted. So let's look at this one here. We already identified that we want this to be our u. So according to the formula, to find dy dx, we need to get dy du and times that by du dx. Now, what we can do here, y is equal to the root of u, we can rewrite this as u to the half power. Is that good with everyone?
Yes, sir.
Square root simply means to the half power, right? U to the half power. When we differentiate y, we get dy du.
Sir,
So let's differentiate that. Yeah, go ahead.
sir, to the root of u,
You sure?
2 multiplied by the root of u.
Let's take our time with it. Simple differentiation. What do we do with the power?
Subtract 1, sir.
Before we subtract 1. When we differentiate, what do we do?
Multiply by the coefficient.
Multiply.
So it's half times u, and then we take 1 from the power. What is half minus 1?
Negative half, sir.
Half. Wonderful. So it's negative half. Right? So I'm going to leave it like this for now. We won't neaten it as yet. We can do that later. So that's basically what dy du is equal to. So dy du is is half u to the negative half power. This is good with everyone?
Yes, sir.
Alright. Now what do we need to do? Are we finished? We found dy du.
We find du dx.
Great. So u is equal to x squared. That's in red here. So du, when we differentiate u with respect to x, du dx, what's x squared minus 1? When we differentiate that, what will we get?
2x, sir.
Wonderful. So du dx is equal to 2x. So remember, it's dy du times du dx. So I'm multiplying now by du dx is 2x. And this is our answer for dy dx. All we need to do now is simplify. Right? So the final step, when you put in your dy du and your du dx, the final step is to simplify. That's basically what you have to do. Now, If you remember your laws of indices, when we have a negative index, we can simply put 1 over the variable and make that index positive. So I hope you remember that. So where I have half, I put back my half. My u to the negative half power can be written as 1 over u to the positive half power. Is that good with everyone? You remember this from algebra, laws of indices?
Yes, sir.
I'm not making
Yes,
this.
sir. Yes.
So I'm just showing you, the biggest thing with calculus is to simplify. The rules are straightforward, but you have to be able to simplify. And we are multiplying by 2x as well, right? So I bring back my 2x. Now, I'm going to continue to simplify. So 2x times the ones at the top here, what will be my numerator?
Two x.
Right, 2x. My denominator will be 2. Now u to the half power is the same as the root of u. True or false?
True, sir.
Great. Can you see any cancellation going on there?
Yes, sir. The 2.
Look here. Great. So I can cancel out these 2's. So I'm left with x over the root of u. And that's my dy dx. There's one last thing I have to do. Can anyone tell me? I can't supply this as my answer because I didn't start with u. This was my original function. So what do I have to do finally?
Sir, you substitute the u value?
Of course. So we substitute back the value for u, and the value for u is x squared minus 1. So our final answer would be x over the root of u, which is x squared minus 1. So that would be my dy dx. Good. Are we going to do this one? It's a lot of simplification, but the rules are the same. You let the inner function be u, you find dy du, you find du dx. Substitute. That's basically the order. All that we did here, from here to here, is simplifying it. At this point here, we have our answer. So all of this here is simplifying. That's where algebra comes into play. Good. So I'm going to do the final one. And that is why you were allowed to do calculus. And that's why the college had made it necessary for students to do. If you failed algebra, you could not write calculus. Before, that used to happen. Persons failed algebra, they wrote calculus, and most of them failed calculus. So the college took a strict stand to ensure that if a student fails algebra or did not do algebra, the student cannot or should not go for to do calculus, because algebra is the base of it. Calculus is all about a set of rules.
Yes, sir.
And when you apply the rules, you have to simplify, and that's where algebra comes in. So you can find that students know the rules. They know multiply by the power, subtract 1 from the power. For differentiation, they know that the chain rule is dy du over dy du times du dx. They know the rules, but when it's time to simplify, they cannot. That is why algebra is so important.
Yes, true, sir.
Right? All right, so the final one, before we actually work